Traceroute is a way that we can see the path that our packet takes throughout routers out to the internet and its way back to us. This can help us troubleshoot if we're on a local network. If we have a big corporate network and it's all internal, we can trace a path through our internal network from source to destination because we might have an internal routing problem, or we might have some connectivity problems going out to the internet. Traceroute can help us out. The instructions in this exercise emphasize Linux. You can run this in the Amazon Web Services cloud, but because of the way the networking works in the Amazon cloud, the routes aren't as interesting. So I'm actually going to run this from my Windows desktop. So I'm going to adapt these instructions slightly to work on Windows using the Windows command. But the instructions in this exercise will show you the equivalent commands to run this in Linux. The names of the tools are different. On Windows, we run tracert for traceroute. On Linux, you have to type out the full traceroute, R-O-U-T-E. This is one instance, maybe one of the only instances, where the command is actually shorter in Windows than it is on Linux. So let's get into it. If you're running this on Ubuntu server in the cloud, you actually have to install the traceroute application. It doesn't come with the Ubuntu server, the version in the default Amazon machine image, so you do have to install it. I'm going to open up PowerShell. Every Windows computer comes with traceroute installed by default, so I don't need to install anything on Windows. But instead of that sudo traceroute-i google.com, I'm just going to run tracert google.com. And let's take a look at what's happening here. So I can see I'm going out to the internet. So Spectrum, that's my internet service provider. So not shocking that once the packet leaves my house, it's going to go to my internet service provider. I can make out here, it looks like it's going to Marquette, Michigan. I live in Marquette, Michigan, so I'm going to some kind of hub here in Marquette before that packet moves out. I'm seeing a couple of instances of this request timing out. Similar to how some servers just don't respond to ping requests, the routers going along my destination from my computer to Google, they might not all give me this requested information. And so occasionally I might see this timeout, and that's fine. Eventually I got out. It looks like I went to Chicago, Illinois on the Charter network, still in Chicago. And then at some point, this packet's going to make it into the data center that's hosting the content for google.com. So once we're in the data center, we'll see who responds. Okay, the 14th hop, we eventually did get to something. So 1e100.net. 1e100, that's the scientific notation for a Google, the number. So we eventually did get to Google's data center. So I was using IP version 6. If you're using IP version 4, you would just see IPv4 addresses there. Just for funsies, if I try that trace route again, but if I put -4, that'll force it to use IP version 4. So we'll see. It should take a very similar route this time. So we start on my local router. We see the IP address. This utility will try to do a reverse lookup, a reverse DNS lookup. So it'll take the IP address that it found and try to resolve that to a domain name. And not shockingly, we are going in Marquette, Michigan. We do see a little bit more information here about the intermediate stops. Looks like we're going to Wisconsin. Looks like we went to Stevens Point. And I'm going to mispronounce Eau Claire, probably. Is that the right pronunciation? A couple of hops there. Must be a big hub for Charter down there in Wisconsin. The way that this traceroute typically works is that it sets the time to live and tests the speed, where that packet will die. How long did it take to get from one hop to another? Each one of these represents a different router on the internet, all working together to move the packet from my home to Google's server. So we did end up in Chicago again, not surprisingly. We're probably in a data center at this point around these hops until we get to Google's server. So all that's just fine. So when I see the latency here between all these connections, it's pretty good. I don't see any problems. If I did have a problem inside my company where we control all the hops within our internal network, we might see really good response time, and then we might have one router that's super slow. Maybe it's getting too much traffic. Maybe it's a bottleneck in our network, and that's where we would need to maybe increase the bandwidth, use a faster connection to make our network perform better. So trace routes used for a couple of things. One, just telling us just the path where our packets are taking to get from one point to another. That information can be used to troubleshoot network connectivity issues, slow connections, things that we might want to fix later.